Good morning students, welcome to the class. I am Rajni, your science teacher in DAV Police Public School, Kethan. Students, we are studying the chapter metal and non-metal. So we have differentiate the metal and non-metal on the basis of their physical property. As we know that metal are lustrous, they have the shiny surface, but non-metal, they do not have the shiny surface. Metals are hard, but non-metals are soft. Metals are malleable. It means metals can be beaten into thin sheets like gold and copper, aluminium and zinc sheet. So metals are non-metal, they can be beaten into thin sheet. Metals are ductile. Metals can be drawn into thin wire like this zinc wire and gold wire. The metal are ductile. Metals, they are the good conductor of heat. They are used for making utensils because they are good conductor of heat. Metals are good conductor of electricity also. Therefore, the metals are used in making the wires. Metals are sonorous. When they hit to hard surface, they produce sound. Therefore, metals are sonorous. So, on these property, we have classified on these physical properties, we classified the metal and non-metal. But on these physical properties, we cannot classify the metal properly. We cannot differentiate the metals and non-metal only on the basis of these physical property. So we differentiate the metal on the chemical properties of metal. How the metals react with chemicals. How the metals they react with chemicals is called the chemical properties of metal. When the metals burnt in air, when the metal dissolve in water, when the metal dissolve in acids, or when the metal dissolve in any other salt, how they react.
There's just one simple thing we will do. We will look at how reactive the metals are. If the metals react easily, may it be with oxygen or air or anything else, we say that they are more reactive. When it's more difficult for them to react, we say that they are less reactive. Let's focus on the first category. Metals burnt in air. The most important points to note here is that almost all metals react with oxygen to form metal oxides. These metal oxides that are formed are usually basic, but they can also be amphoteric. What do we mean by amphoteric? Metal oxides which may show acidic as well as basic behaviors are known as amphoteric oxides. Most metal oxides are insoluble in water, but some may also dissolve to form alkalis. Okay, so metal oxides being formed in one thing, but do all metals react with oxygen at the same rate? Not really. Different metals show different levels of reactivity towards oxygen. Alkali metals such as sodium and potassium react vigorously with oxygen. In fact, they react even if they are just kept in the open, that is at room temperature. They don't even need fire to ignite the reaction. What about the other metals? Metals such as magnesium, aluminium, zinc and lead also react with oxygen at room temperature, but they react a bit differently. When they react with oxygen, their surfaces get covered with a thin protective layer of oxide. This layer protects the inner part from being oxidized. What about iron? Iron doesn't burn on heating, but iron fillings burn vigorously after being heated. And which metals do we have at the end of the spectrum? Yes, silver and gold. Can you guess how they react with oxygen when burnt? Silver and gold do not react with oxygen at all. Yes, they don't react even at high temperatures. So we see somewhat of a pattern event amongst the metals. Sodium and potassium are more reactive, whereas magnesium is relatively less reactive. But wait, burning in oxygen doesn't really help us to decide about the reactivity of zinc, iron, lead or copper. All we know about these four is that they form a thin layer of oxide around the metals. So just this category of burning metals in air isn't enough for us to judge the order of reactivity of these metals. We can see a few more reactions to judge the order of reactivity. So in the next lesson, we will see how metals react with water.